Solve the system by graphing. Y is less than 3x minus 5, and 9x minus 3y is less than negative 6. I'll look at the first inequality. Y is less than 3x minus 5. So that it's in a slope-intercept form, has the y-intercept of negative 5 and a slope of 3. So assuming a scale of 1s, we have the y-intercept at negative 5 and a slope of 3, so up 3 and over 1, and we'll use a dotted line. So we have something like this. And since its y is less than, and we can test a point, let's use the test point of 0, 0. And so we would have 0 is less than 3 times 0 minus 5. Is 0 less than negative 5? That's false. So we would shade the region that does not contain 0, 0. We would shade the region below that line. Now let's focus on the second inequality. We have the 9x minus 3y is less than negative 6. I'll work in red for this inequality. And we could use, let's use intercepts for this one. So let's think of 9x minus 3y equals negative 6 for a moment. Letting y equal 0. Then I'd have 9x equals negative 6, and so x is negative 2/3. Letting x equal 0, then I'd have negative 3y equals negative 6, which implies then that y equals 2. So my x-intercept is negative 2/3, 0, and my y-intercept is 0, 2. So plotting those 2 points, negative 2/3 comma 0 is about here, and 0, 2 is there, and again using a dotted line through those points. And it appears that these are parallel lines. And again, how about we test the origin? If I test the point 0, 0, I have the statement that 9 times 0 minus 3 times 0 is less than negative 6, which simplifies as 0 is less than negative 6, which is again false. So for that second line, I would have to shade the region that doesn't contain 0, 0, which would have been this part. And so notice that these are parallel lines, and there is no intersection. There's no place that satisfies both of the conditions. And so what we would have to say is that there's no solution to this inequality. Now let's compare that to the second example, and notice that they're the same inequalities, almost the same. I changed one piece. So notice that the only difference here is that I have a y is greater than in the first inequality, but otherwise they're the same. And so my blue inequality was what? 1, 2, 3, 4, 5. It looked roughly like this. And so now, instead, we'd be shading above that line. And my red inequality, through negative 2/3, 0, and 0, 2, it would look roughly like this. And we would again be shading above that inequality, because that one didn't change. Now, where is the intersection of those two shadings, right? So really that's the only part that we should actually be shading is the intersection. And that intersection would be the region only above the red line. And so I've shaded that in purple, the combination of red and blue.